Okay, so today's topic is topic 4, which is on flow rate and viscosity. All right, so let's get straight to the key terms. What is viscosity? So this is the property of fluids or liquids in this case. It's the property that describes a liquid's thickness or thinness, but it is a property of all fluids. And remember, fluids consist of liquids and gases. All right, so it's a property of all fluids, including liquids and gases, whether they're pure substances or mixtures. It is more difficult to measure viscosity of gases. So when we are talking about a thicker liquid, we can say it's more viscous and it has a higher viscosity. And then we can measure its flow rate. So basically, the time it takes for a fluid to flow from one point to another. And there is an experiment or investigation we'll look at afterwards of how you can measure flow rate of different liquids. Come back to this. Okay, so the lower a fluid's viscosity, the higher the flow rate. So let's say compare water to honey, right? So honey is more viscous compared to water. Water has a lower viscosity. So therefore, water will have a higher flow rate and honey would have a lower flow rate. And viscosity of all liquids is also related to temperature. So if you increase the temperature in liquids, the higher the temperature, the lower the viscosity. This is an investigation you're doing for homework today. I just have it here, but it is for homework today. So let's take a look at how does the viscosity of liquids vary. So why do some liquids flow more slowly than others? It's basically because they have different viscosities. They're flowing at different rates because they have different viscosities. So it's something called resistance to flow, which is another way to define viscosity. And what's happening is there is internal friction. So friction is when two surfaces are rubbed together, and what's happening is there is some resistance happening within these fluids as well. So it's easier. What did they say? It is easier from some fluid particles to move past each other compared to other fluid particles. So, for example, in water, the water particles, they have an easier time slipping past each other. But when you look at oil or something more viscous, they have more internal friction. So they are not able to flow past each other as easily. And the reason being is there are attractive forces, like we talked about when we were looking at the particle theory or the particle model of matter, that there are attraction between particles. So some attractive forces are stronger in some fluids than others. So therefore, when we're looking at oil compared to water, the attractive forces in oil particles are strong. So now if we look at temperature, so if we increase temperature, the attractive forces now are going to decrease between the particles. So as temperature decreases, the attractive forces increase. So think about honey. I like to use honey as an example. If you have honey sometimes sitting in the back of your cupboard, it goes it goes hard, right? It becomes thicker. So if you heated it up, if you put that honey into hot water, soon it becomes thinner. So therefore, increasing the temperature of it made it more thin. So this example here was talking about if you decrease temperature, the attractive forces increase. So if you decrease temperature, think about coconut oil or honey. If you decrease temperature and you're making the temperature cooler, then that honey or that coconut oil becomes more thick. But if you increase temperature, it'll again become more thin. Okay, and then warmer liquids, they are going to be able to flow more quickly. Cooler liquids will flow more slowly. All right, so just when we're talking about viscosity, the viscosity of liquid, it will decrease as it's heated, and it will increase as it's cooled. All right, so if you heat up, for example, honey, it becomes less viscous. Okay, so just summarizing, temperature of liquid and the effect on viscosity. You increase the temperature, you're going to decrease viscosity. If you decrease temperature, you're going to increase viscosity. So warmer liquids will flow more quickly, cooler liquids flow more slowly. The example here, honey goes hard, it becomes more viscous at room temperature. But if you heat up the bottle, like put it under hot water, the honey becomes more runny, therefore it becomes less viscous. Okay, how does viscosity of gases vary? Now, gases are going to they are going to behave a little bit differently. So generally, gases already, they flow more easily than liquids. The gas particles are already so far apart, so attractive force is already so low. So particles of gas are more likely to collide with each other than rub against each other. So for example, if you have a balloon and you untie the balloon, the air flowing out of a hole. You can think of it in a tire or out of a neck of a balloon. If the gas particles have low energy, the particles are moving in the same direction and the viscosity is low. So gas will flow quickly and easily out of the opening. When we increase the temperature of a gas, the gas particles, they gain energy, and now there's more collisions happening among the particles. So now internal friction is high and the gas will not flow easily. So when we talk about gases and temperature and the effect on viscosity, as temperature increases, gas particles, they gain energy, they move faster, and there's more collisions. Cooler gases contain particles that are not colliding as much or as often. So we see the opposite of liquids. If you increase the temperature of gas, it will increase viscosity. If we decrease the temperature, it will decrease viscosity. All right, so next we're just going to watch a quick video on viscosity of liquids. And the homework I said already is going to be that investigation in the textbook on page 47. I'll show that again.